3.8 is this last thing that's in Unit 3, and it's only there for one small, tiny connection. That small, tiny connection deals with congruency. What we've been learning about in Unit 3, the main idea is how to prove one triangle is congruent to another triangle. Like, that's why we learn side, 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 angle, 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 side, and HL. You learn those 5 shortcuts to prove that two things are congruent to each other. What we're going to try to make the connection on now is that when you translate or reflect or rotate something, it's still going to be congruent because all the sides are the same and all the angles are the same. And this works for any polygon. So what I just basically need to do is I need to review with you what you learned either last year in Advanced Math 8 or in Math 1. You learned all 3 of these things: translations, reflections, rotations. What you may or may not remember are some of the little details which I'm just going to review with you. These are called rigid motions because the object's size does not change. If it were to get bigger or smaller, that would be a dilation, and dilations are not rigid motions. They are not isometries. So let me remind you a few things. First and foremost, the thing that you move before it moves is called the preimage. It's usually just labeled with the letters like triangle ABC. The thing after it has been reflected or rotated or translated is called the image. The image has these things called primes. In English class, they're called apostrophes. In math class, they are called primes. A prime. B prime. B prime is the image. B prime is the point that has been through either a translation, reflection, rotation, or a combination of both of those things. Okay? So that brings us to the 3 types of transformations you're going to be expected to know. Translations, reflections, rotations. Sometimes more than one. A translation can be written in either in coordinate notation or function notation. Our textbook will be using function notation more than it will be with coordinate notation. This is kind of probably how you learned it last year. If you're translating something or moving something to the left 3 units and up 4 units, it would be written like x minus 3 or y plus 4 because you're going to the left 3 and up 4. That's how you probably learned it. Our textbook goes into this thing called function notation, which has these angled brackets. And it just says -3, 4. And what that means is it's being translated to the left 3 and up 4. This kind of notation is also used in physics. I have seen this in the Physics 1 course, and it's called vector notation. I used to teach something similar to this in my AMA class back when I used to teach it, and I would talk to Mr. Lake about how he uses this as well. And just so you know, so if you see it like this is the shortest way possible to write it. We're going to use this same notation. But be mindful that you can write it in both ways. If you were to write it this way or this way, I would accept both on any quiz or test, just so you know. The shortest, easiest way is this way, so this is how I'm going to try to show it to you. Reflections, on the other hand, have a capital R in function notation. The only difference between a reflection and a rotation is the reflections have the capital R, where the rotations have a lowercase r. So if I'm trying to remember that, I just go and look at reflection has something that you're reflecting over, like the x-axis. And a rotation will have a degree measurement of how many degrees you are rotating it and about what particular point. O would stand for the origin, or 0, 0. I need to remind you that for a reflection, you are going the same distance to whatever your line of symmetry is. You can use the x-axis or the y-axis or the x and y axes. You can also reflect across a diagonal. If I see y equals -x, that would be a line that looks like this. It goes down 1 over 1, down 1 over 1. This is a line y equals x. I can reflect something over diagonals as well as an axis or a vertical line or a horizontal line. I say that to you because a lot of people get confused with the x and the y. So let me just kind of go to this little blank one that's right here. Here's some blank graph paper. A lot of people know that this is like the y-axis. But if I say y equals 2, and you have to count like, let's say 2 spaces up, this is y equals 2. It's a horizontal line. Don't forget that. So let me just kind of like draw something real quick. Like if I have this, and that's 0, 0, and I say this is the x-axis, which it is, but x equals 3, you go 1, 2, 3, and all the x's are equal to 3 is a vertical line. Don't get confused between an x-axis and a vertical line. When we have that vertical line, x equals 3, it's because 3 comma 1 is right here, 3 comma 2 is there, 3 comma 3, 3 comma 0, 3 comma negative 1, and so on. All the x's are equal to 3 on this line. It makes a vertical line. That's something that you should make sure that you know the difference of. I don't think that a lot of you have too many issues with that, but that's a common mistake that I see. Reflections, rotations. If it doesn't say it's counterclockwise, 90 degrees which way? Well, if it doesn't say, counterclockwise, up and to the left, about the origin. I am going to try to show you how to do these translations in the shortest amount of moves possible. Of course, you could come up with 3 to 4 to 5 different steps to get there, but if you can do it in one step, do it in one step. That's my goal for you. I will not mark you wrong if you do it in more than the minimum amount, but I just want you to do that as well. A few other things. I have Paddy Paper if you need it. This is Paddy Paper. What's nice about Paddy Paper is you cannot see through it until you set it down, and then you can suddenly see through it. It's like tracing paper, which is nice. When you're trying to trace something, can't see anything through it, oh, then you can. That's pretty cool. I also have these shorter rulers, which you can use as well, because you have a lot of graph paper in your book. Paddy Paper. This stuff is on my desk. You'll be able to use it during every quiz, during any test, and on the homework today. So, this is part of your first homework assignment if you want to open your workbooks up to, I believe, page 182. Am I right? Okay, 182. Number 2 is the same question that I have highlighted here. It says, what is a rule that describes the transformation from each preimage onto each image? That means that we're going from the blue one to the red one. Why do I know that? Because this one doesn't have primes, and the D prime, E prime, F prime means that this is the one that got moved. It doesn't look rotated. It doesn't look reflected. This one looks translated. What I should do if I'm thinking about a transformation, I can write this in either coordinate notation or in function notation. I'm going to write it in function notation. You can make your choice if you want. But I pick a point. I'm picking point D, and I'm going to look at D prime. How did I get from D to D prime? I'm going to count. I'm going to start with my x-axis. 1, 2, 3, 4, 5, 6 spaces to the left. So I'm going to put -6 for my x's. And then I'm going to count for my y's. I went 1, 2, 3, 4 units down. And if I did that correctly, then no matter what point I pick, I can look at point E and I can count and see if that's correct. 1, 2, 3, 4, 5, 6 down. 1, 2, 3, 4. Did I get to E prime following this rule? If I did, then I'm doing this correctly. I can even pick a point in the middle of this thing, like let's say I pick this midpoint, I can go to the left 6, 1, 2, 3, 4, 5, 6, and down 4. 1, 2, 3, 4. And guess what? You get the same midpoint over here because you're moving every single point on that triangle. And this distance is the same as this distance, and this distance is the same as this distance, and this distance is the same as this distance. Guess what? These are congruent by side, side, side. I don't even need to know what the angles are. They're congruent to each other. So this is how we would write it. That's number 2. Let's jump to number 4. The first thing that I noticed about number 4 was they have all this lovely graph paper for you, but they don't give you any axes. So the first thing I would recommend that you do is I would do this if I were you. I would draw an x-axis and a y-axis, and you can just use a ruler if you want to. For me, I'm going to cheat a little bit and use the computer because my computer can draw pretty straight arrows when I start. Then it says, triangle DEF has vertices at -7, 2. You can label your x-axis and y-axis if you want to. You can count every number if you want to, but I just go over 1, 2, 3, 4, 5, 6, 7 to the left and 2 up. This is my point D, and I label it. I do the same thing for E. I do to the left 2 and up 5. 1, 2, 3, 4, 5, and I label that point E. And then I label point F, -3, -3. I'm hoping you already know to go to the left and down 3, and that's F. I would like you to connect your dots. I would recommend using a ruler. If you do not have a ruler, you can borrow one from me. I am going to use my straight line on my computer so that I can draw you triangle DEF. This is telling me to do something. This is telling me to do what? Say what word I'm supposed to be using out loud. Reflect. Good. Over or across the y-axis. So you got to know which one your y-axis is. That's this vertical one, the y-axis. The way you do a reflection is you count how far is this point from the mirror. Think of the y-axis as your mirror. It is 2 units away. So if E is 2 units away from the line, I go over 2 units and E prime needs to be there. I can look at D and I can count 1, 2, 3, 4, 5, 6, 7. It's 7 units away. I go 7 more. 1, 2, 3, 4, 5, 6, 7. Along that line, that's where D prime needs to be. F is 3 units away from my mirror. The mirror is going to be the equal distance away. Reflections, just like the mirror, are going to be equal distances away. I want to switch colors. Switch over to blue. There we go. Let's do that. That way my reflection is a different color. Number 4 asked me to reflect DEF, and I wrote this. I was very specific. This is called D prime, E prime, F prime, so that I have a reflection that is congruent by side, side, side. I could prove it by finding this distance and this distance and this distance, and they would be the same. My last example for you is on the next page. If you jump over to number 3, I want to say this might be on 185. Okay, thank you. The directions are at the top. It says, for each coordinate grid, identify a pair of congruent figures. Now, I thought that was pretty lame because I don't think you're going to think this and this are congruent. If you do fall for that, then there's something wrong, right? Because there's only two congruent, which identify a pair of congruent figures. Oh, these two are the ones that are congruent, right? Like it's simple. Then determine a congruence transformation that maps the pre-image to the congruent image. Now here's the problem with that. Your textbook says that maps the pre-image to the congruent image. Well, is there any way for me to tell which one the pre-image is and which one the image is? There's no way. So I'm going to do something for you. Make sure whenever I give you anything that you know where you're beginning with and what you're going to end with. These are your original ones. You can just kind of like, I don't care about these letters. These are going to be your image ones over here. And we're going to figure out what goes where in just a second. I know it's kind of hard to see. So sometimes I will add the X and Y axis here. Here's the Y axis. Here's the X axis. I try to make it a little bit bigger for you. You get to decide how you want to do this. You could do this in 2 steps. If you did this in 2 steps, you could see that you might want to reflect over the X-axis and then the Y-axis, or you might want to reflect over the Y-axis and then the X-axis. I'm not sure. But as always, if I could figure out how to do this in the shortest amount of steps, then I'm going to try to do it in the shortest amount of steps. If you are a Paddy Paper person, what you would do is something along the lines of tracing the X and Y axis, tracing your shape, and then you can even think about, I'm trying to do this without touching the screen and moving the image, which is not the easiest thing to do. I almost have to use chopsticks. Let's see. There we go. That's 90. Or maybe you can just rotate it 180 degrees. That's kind of what I see. So if I'm going to write this as a rotation, is that a capital R or a lowercase r? How many degrees did I rotate it? 180. You could go counterclockwise or clockwise, it doesn't matter, but I'm just going to assume it's counterclockwise. What did I rotate about? The origin. So I'm going to abbreviate that as the letter O for the origin. This is a rotation of 180 degrees. And what did I rotate? It's not a triangle, it's a polygon. A, K, E, F is what we actually rotated. We rotated A, K, E, F, and we rotated it 180 degrees about the origin. That's all the notes that I have for you. Oh, before I forget, let's say you don't have Paddy Paper. Is there a way to do rotations without Paddy Paper? Sure, let me show you how I would do it. If I wanted to rotate this point K around the origin without Paddy Paper, I would just count up 1 unit and over, and then I would rotate that up and over the same amount of degrees. 90 would be this way, 180 goes this way, 1 and this way. That K becomes K prime right there. Then I would erase that. Let me find my eraser just a second. There it is. Then what I would do to find A is I would go up 2 and over 1. I could rotate that 180 degrees and go down 2 and over 1. This is where A prime would be. I would erase that. If I wanted to find out where this point rotated, I would go up 3 and over 1, and I would rotate that 180 degrees, 1, 2, 3, and over 1, and that's where F prime would be. Lastly, once I erase those, I count over 1, 2, 3 spots for E, and I could rotate that 180 degrees and find out that E prime is there. So that whole thing can be found without Paddy Paper by rotating it 180. Some of the ones in yours will use 90, 180, or 270. I'm going to stop your notes right there.